Hello guys, I hope all is well. Welcome back to Manalas Arc. So here today we want to talk about grade 8 revision about a topic about the ratios. So without wasting any time, let's get straight to it. Let's see here. So what happens here? Ratios come in different ways. Okay, let me see. How would I say this one? How would I put this one? So for ratios, oops, let me fix that. Probably need to fix this pen because it seems tired now. When you talk about ratios, we are talking about the comparison of two quantities, like comparing this and that. But what happens is that those quantities, they need to be in the same unit, especially if you are measuring the same quantity. So now we have the conversion factor, whereby we use it this way. King Henry died miserable death called measles. King Henry died miserable death called measles. So here we have kilo, here we have hectare, here we have deca, here we have meter. Let me put a square on this one and then I'll come back to this. I'll tell you why I put a square. Then we have deci, we have centi, we have milli. King Henry died miserable death called measles. So there's a nonsense method because there's not death called measles. Measles, it's a disease, I think. Yes, disease. So now, but then the sentence is crammable and it's easy to remember. And then once you have this sentence, then you remember that the K is for kilo, H hectare, D deca, M meter. It's capital M here. From M upwards, it's capital. And then from here, it's a lowercase sentence. So we have not sentence, wait. And then here we have small letter, small letter, small letter, right? So now the reason here I put this, it's because this can be anything. This can be meter, it can be grams, it can be newtons, anything, any unit we use to measure. It can be liters instead of meters. So whatever we are working with, we can either work with something that we measure in liters, or we measure in meters, or we measure in grams, or we measure in newtons, or whatever unit we use to measure. But then the other ones, they stay the same. Kilo, hectare, deca is the same. So here when we have meter, if we're working with liters here, it's kiloliter. If we're working with grams, it's kilograms. Makes sense. And then if we're working with liters here, it's milliliter. If we're working with grams, it's milligrams. If we're working with meters, it's millimeters. Make sense? Perfect. Now, what happens is that you might, on ratios, there are two things that might happen. You might be asked to simplify the ratio. And then you might be asked to perform the basic operations. Basic operations, what are we talking about? Talking about three things here. You might be asked to increase a number by a ratio. You might be asked to decrease a number by a ratio. And you might be asked to divide a number by a ratio. So when it comes to simplifying now, when it comes to simplifying using a ratio, this one is easy, very doable. All you have to do is to make sure that the ratio is simplified. Now let me give examples to that. So they might give you a question that says simplify the following ratio. You have 20 to 100 to 160. Now I want you to follow the following now. Like there are many ways you can do this. It's not that easy, but there are many ways you can do it. So whenever you simplify a ratio, basically you're supposed to find a number that divides into all these values, which is the highest common factor for all of them. So you want to find that and divide by that. But sometimes it might not be the case. You might not be lucky to find the common factor at your first try, right? So let's say you take, okay, you can see 10 can go into this, 10 can go here, 10 can go there, and then you decide to divide this by 10. So which means now here you'll have 20 divided by 10, this divided by 10, and this divided by 10. This will lead you into getting which answers? Here you would get 2, and then here you would get 10, and here you would get 16, right? You are now here, right? But then this ratio, there is still a number that can go into all of them. So you still have to divide again. So it makes sense. You might try to simplify the first time and realize that it doesn't work. What you have to do, you don't have to scratch out and cancel everything. No, you continue simplifying, you continue dividing until there is no number that can divide into all of them besides 1. So I see that 2 goes here, it goes here, it goes there, right? So I divide this side by 2, divide this side by 2, and divide that side by 2. So now this leads me to what? This leads me to having 1 here, 2, 5, 2, 8. Now, the only number that can divide into these 3 values now, it's only 1 and nothing else. So now it's simplified, right? So when we say simplify by a ratio, this is where you land, right? Now let me give you another one. There's a different one. They don't all come this easy. Sometimes you get a number like this one, and then they're saying simplify this ratio. Now, what is that? How would you do that? First, the issue is that here you have a fraction and here you have a whole number. So the main thing to do here is to convert this whole number now into a fraction. So 3 over 5 is the same as what? How do you write 2 as a fraction? You divide it by 1. It's 2 over 1. All set. And then from there, what you want to do now is for you want to have the same denominators. Let me use orange. Maybe you'll see it better. You want to have the same denominators. Oops. Take that back. Take that back. Orange seems like it's not a good idea. Yes, you want to have the same denominators. Now, how would you do that? So you'll take this 3 over 5 and you'll take this 2 over 1. Then you'll multiply them with numbers that will make their denominators the same. In math terms, we are saying you are looking for, choose a proper color here. You are looking for the LCM. The LCM of 5 and 1 is what? It's 5. So which means now I'll have to multiply this side by 5 over 5 so that this number can be the same as this one. Makes sense? So now what will I end up with? I'll end up with 3 over 5, 2. This times this one is how much? It's 10 over this times this, that is 5. Makes sense? Now that the denominators are the same, we drop them. We don't cancel them, we drop them. You move on to your answer now. You have 3 is to 10. You see what I did? I didn't cancel the 5s. I just said when the denominators are the same, you drop them. And then if there's a way for you to simplify this now, you'll continue simplifying like we did in the previous step. But then here in our case, there's no number that can go into 3 and 10 without leaving a remainder except for 1. So it's simplified here. If it was possible for you to simplify this further, you would have to do it. Hope it makes sense. So it doesn't end there. I'm sure some of you are asking yourselves now that, you know what, Mr. Manala, now what do we do with the nonsense method you showed us there on the right? Now, this is where it comes in. Let's say you have a question that says, simplify the ratio of 20 kilometers to 10,000 meters. Do you see that? Now, this is where this method comes into play now, but I'll have to remove it for me to have some space for calculations here. Let me remove all that and save some time. So I will say King Henry died miserable death called measles. Do you see that? And then I have to convert some of this number, one of these numbers. I have 20 kilometers, I have 10 meters. Our ratios have to be in the same unit. I cannot have a kilometer and a meter. We can see that they are all measuring distance, but I cannot measure distance now in different units. One is kilometer, one is meter. I have to convert one to the other. So 10,000 meters is a huge number. Let me see if I can convert that now into kilometers. You see that? So this one here, 10,000 meters. Is it a kilo, hectare, deca, meter, deci, centi, or milliliter? It's a meter. It's this one. So I write the value here. 10,000, right? Where am I moving it? Am I moving it down here? Or am I moving it up there? So because this one, it's in the kilos, then it means I must move this to the kilos. Makes sense? I hope so. So now, here we go. In this case, whenever I move this value upwards, it loses a 0. So now I'll end up having, let me choose a thicker pen. Right here. So now I'll have 1, 0, 0. And instead of having 4 zeros, I'll have 3 zeros. Make sense? Yes. And then when I move from there to there, I lost 1 0, right? When I move from here to there, I need to lose 1 0 again, one step at a time. So I'll have 100 there. And when I move up again, I'll lose another 0. So it's 10. You see that? So that's how we have. So here I have 20 kilometers to what? To 10 kilometers. Now they are in the same unit. 10,000 meters is the same as 10 kilometers. See that? So now that I have this, I can simplify the ratios now. Which number goes into 20 and 10? The highest common factor there, it's 10, of course. So I'll divide this now. I'll divide this side by 10. I'll divide this side by 10. Here I'll be left with 1 kilometer. And then here I'll be left with 2 kilometer. 1 is to 2. That's the ratio. I mean, 2 is to 1. That's the ratio. That's the ratio in its simplest form. There's nothing else that can go between them except for 1. Hope it makes sense. Now, I won't give you another question on this one. We are like almost done. In fact, we are done when it comes to simplifying ratios. I want to show you something now, that what would happen if they ask you to convert the following. Let's say they would ask you a question that would say, convert for us Convert for us 50 meters into kilometers. Now that's a tricky one now there. So obviously you would continue with the nonsense method. Let me erase this. You would continue with the nonsense method. And then you figure out, when they gave you 50 meters, where does it fall? Kilo, hectare, deca, meter, deci, centi, or milli. It falls here. 50 falls here, right? We said when you go down, it's when you're going to the millis. And when you go up, it's when you're going to the kilos. So now, they gave you this. Are you supposed to go down or upwards? Are you supposed to go to centi, to deci, or to milli? No, they told you to go to kilometers. That's what we want. So, but then this is a small number. What happens if it keeps on moving upwards? And we said whenever a number is moving upwards, it loses zeros. This one only has 1 0. It only has 1 0 to lose. So what happens there? What happens is that when we move this upwards here, it becomes a 5 because it lost 1 0. When we move it up here again, now there are no longer any zeros to move. We move what now? A comma. You see this comma, that is a 5 has a comma in front of it, right? Now we'll move the comma here. So which means we'll have 0, 5. Make sense? And then when you move it again upwards, you'll end up having what? 0, 05. So now 50 meters is the same as what? 0, 05 kilometers. Basics. You see that? Now, if they told you to convert this 50 meters into centimeters, what you are going to do, you're going to move this 50 here it was going to gain a 0 now. It's 0, 0, right? When you move it down again, it becomes what? 0, 0, 0, 5,000. You see that? So now 50 meters is the same as what? 5,000. 50 meters is the same as 5,000 centimeters. That way. Makes sense. You must know how to convert with the nonsense method. You'll need it a lot, guys. You'll need it a lot. So now let's remove that. We pause here. So now here we have the following: increasing by a ratio, decreasing by a ratio, or dividing by a ratio. So now what happens there? Oops, made a mistake there. Now what happens there? Whenever you have to increase by a ratio, we reduce the thickness of this and choose this one. Is it too light? Let me choose this one. Much better. Now, whenever I increase by a ratio, let me give you two questions that ask you the same thing. Increase 50 grams by a ratio of 5:2. That's the first question. The second question: decrease 50 grams by a ratio of 5:2. So same questions. They're just asking things that are almost the same, but it's the same thing, basically. Hope it makes sense. Now, how do you increase 50 grams by a ratio? So you're going to say 50 multiplied by a fraction to get an answer. So what do? When you increase, you use this ratio here. You're going to say the bigger number goes above, the smaller number goes below. And then you multiply 50 by that. And then guess what? You don't even need to show me all the steps. Best believe what I want you to do is to just go on your calculator, put this value there, multiply by, because I know most of you can't use a calculator. I have to show you now. This symbol here that you see, this is the fraction sign. Then above there you put your 5, and then here you put your 2. Then you say equal sign. You get your answer there. 125. So this is 125. 125 what? What are we working with? We're working with grams. So this is 125 grams. We increased 50 by this ratio. It became 125 grams. Easy as that. Now in this case, you do the same thing. Now you have to show me the step whereby you say 50 multiplied by a fraction. It equals to. And then same idea. What is the numerator? Because now we are decreasing, the smaller number goes on top, the bigger number goes below. And then you pull out your calculator again. You're going to say 50 multiplied by a fraction. On your numerator you have 2, on your denominator you have 5. Your answer is 20. So which means here you'll get here and tell me that our answer is 20. What are we working with? Grams. So which means my answer is also supposed to have grams. Don't give me an answer without any SI units, guys. So that is that. Now let's move on to the questions, how you'd expect them. Oh, no, sorry. I have to divide by a ratio. I'll show you that just now. So here's a question that says divide 500 by a ratio of 3:2:1, right? So now here's what you're going to do. Whenever you're dividing by a ratio, what you want, you multiply this by a fraction. We are multiplying this by a ratio that has how many values? 3. So which means now here we are going to have 3 values. And also another 500 multiplied by a fraction. Now, what happens here is that now, unlike the addition and subtraction, the denominator of this one is you adding all the values in the ratio. So 3 plus 2 is 5, plus 1 is 6. So the denominator is 6, denominator is 6, denominator is 6. Now, the first numerator, it's the first value there, 3. The second numerator, it's the second value there, 2. The last numerator is the last value there, 1. And then you use your calculator for all these things. So for me, what I get here, I want denominator 6 all over, numerator 3. This gives me how much? 20. Oh, sorry, it's 500. I'm supposed to have 500. I'm saying 500 times 3 over 6. How much do I get there? Boom, 250. I write my value there. 250. I was measuring my units with what? With rands. So I'll put rands there. See that? Don't forget to write the units. Then I go back again. I'll say this time I want the numerator of 2 because now I'm on this part here. Put 2 there, equal sign. When you get something like this, you want to press SD so it gives you an answer. Another SD for you to get an answer. Make sense? Good. So here we are going to add 166, comma to 2 decimal places, 67. So here I have 166,67 right there. Next one, I want to have a numerator of 1 there. 1. When you get a fraction, you do what? Press this button here, SD. When you see something like this, you don't know, press what? SD. How much do I get there? I get 83,83 right there. 83,33, sorry. 83,33. Now, what happens there? After you have all your values there, you rewrite this ratio in terms of these values now. Every time you're done with getting your answers, you rewrite the new ratio with those values. So, in place of 3, the answer I got for 3 is 250. The answer I got for the value of 2 is 166,67. The value I got for 1 is 83,33. Now, this is your new ratio there. See how easy is that? Great. Now, let's move on to the next questions. A question on the exam will come this way. It won't be just easy whereby they say, increase this by a ratio of this. They have to give you some paragraphs, some context. And then you use that to answer the questions that follow. So here it says Ruben and Troy buy a ticket for a competition. Ruben contributes 45 rands and Troy 15 rands. They win 660, divide the prize money in the same ratio as their contribution between Ruben and Troy. So what do you do then? You start your ratio in words. A ratio should always start in words. So you're going to say, who are we talking about here? We're talking about Ruben and Troy. Now, you write your the first values that are associated with these people. Which first number ever was associated with Ruben? They said Ruben contributes 45 rands. So which means here I have 45. This is the first value associated with Ruben. The first value associated with Troy, it's 15. So which means here I write 15. Now, what do I have and what do I want? They are saying these people win 660, then divide the prize money in the same ratio as their contributions between Ruben and Troy. So I have a ratio. I'm supposed to do what? Divide 660. I'm supposed to divide this by what? By this ratio here. Makes sense? So what happens there? I'm going to say 660 multiplied by a fraction is equals to how many values does the ratio have? 2. So which means I'll have 2 steps. 660 multiplied by a fraction. And what is the denominator of these fractions? It's 45 plus 15. That will give me how much? 60. 60. So our denominators are 60s. Now the first value is 45. The second value is 15. Then you look for answers there. So that will mean this one I'll say 660 multiplied by 45 all over 60 equal sign, I get 495. So right here I'll say 495 rands. This guy who took out 45 rands from the 600, he'll get 495 rands. And then the other person, how much will they get? $165. So, oh, I almost forgot the last step. So what happens here? After I got this, I'm supposed to rewrite my ratio. From being in this format, it must now be in this format. So the first value is 495 is to 165. Did they say we must simplify the ratio? No. So it ends here. Do not simplify this. Do not. Make sense? Unless they tell you to simplify the ratio, then you can. But here, you do not. Okay, let's move on to the next one. What is the slowest? Now, these are tricky questions because you have to answer this question. This is, oops. Okay, let me fix this. Here we are, yes. It says, what is the slowest? Traveling at this, let me find a highlighter there. Using this, we want to know what's the slowest, right? This is the question we are supposed to answer using the following details. Now, what do we have there? We have the 452 kilometers, we have the 4 hours, we have the 582,000 meters, we have the 360 minutes. Now, that's an interesting question for a grade 8 learner, but I bet if I was setting a test, you were definitely going to get something like that. So, now, let me drink some water. Okay, so now, what is the slowest? First, you need your values to be in the same unit. We have 452 kilometers in 4 hours. And you have 582,000 in 360 minutes. In terms of distance, here you have kilometer, here you have meters. In terms of time, here you have 4 hours, here you have 360 minutes. Now, what type of a question is this? This is a question for rates now. Because ratios go with rates, guys, you have to always be prepared for those things. Rates say we must use distance, time, and speed. And I bet you know the formula from the triangle there. Now, for me to answer this one, I need to find the speed that is traveled in this case. So the formula for speed, it says speed is equals to distance over time. And then where there is distance, my distance is 452 all over 4 hours. Therefore, my speed is equals to, use your calculator there, 452 over 4. You get 113 there. So right here it's 113. And the distance was kilometers. The speed was hours. So which means the time was hours. So which means my speed is kilometers per hour. So this is okay because they said I should express my answer in kilometers per hour. Now I go on to my next friend here. What happens with my friend here is that his distance is in meters. That needs to be converted. So I use the nonsense method. King Henry died miserable death called measles. Where does the 582 fall? The 582,000 falls here. I need to convert it to what? To the kilometer guy there. So when I send it upwards, it becomes what? 582 with fewer zeros. When I send it up again, it becomes what? 582 with 1 0 this time. When I send it up again, it becomes what? Just 582. You see that? Now, it means here now, I can just write my answer as 582 kilometers. That's what this is, right? And then now I need to work with the time. I have 360 minutes. How many minutes are there? How many minutes are there in an hour? Because I need to convert this into an hour. I have 60 hours. So now 60 into 360 goes how many times? It goes 10 times. Listen. No, it doesn't go 10 times. Let me use my calculator, guys. Let me not guess, because I'll teach you guys how to guess in a wrong way. Then you would also get it wrong. 6 times. Perfect. Now, my hours that I have here, it's 6 hours. So I can come here and say 360 minutes is the same as 6 hours. See that? Now I can go to calculate my questions. So if you didn't get to the part whereby you did your conversions, guess what? Your whole step is wrong. And obviously you're not passing. So let's do what we have to do. Choose a white color right here. So now I have to calculate speed. My speed is equals to distance over time. How much is my distance? 582 kilometers. It's now in kilometers. It's proper now. How much is my time? 6 hours. It's proper that it's in hours. Then what is my speed? My speed is 582 all over 6. And that is how much? 97. So I have 97 kilometers per hour. Therefore, this is the slowest. I put 3 dots. These 3 dots in maths, they mean therefore 97 kilometers per hour is the slowest. They didn't say the fastest. They wanted us to tell them the slowest. So now this marks the end of our video. This is probably the longest one, but I hope it helps. I hope it covers the gap. Don't forget to like, share the video to other grade 8s, and don't forget to subscribe. See you on the next one. Enjoy studying maths.